Okay, so all set. So thank you everyone for joining. So this is our fourth meetup on generative AI in the enterprise. I started this meetup back in December, and I'm Ujjwal Bhattacharjee. I work in financial industry as an architect, with over 20 years in the industry right now. But generative AI and EISS like has been like talk of the time all over the place. And luckily, I was into some of the AI initiatives within our company. So, but then I see like there is so much to learn and so much to understand. So I started, meeting with more people, connecting with more people, brainstorming ideas, and then eventually got started with this group so that we can brainstorm, discuss, and kind of like all learn together. So, being said that, um, I do not want to waste a lot of time. I'll quickly hand it over to um, our friend over here, Andrew. And Andrew, thank you so much for agreeing to join and kind of like give your inputs on generative AI. But I'll hand it over to Andrew, but we'll just do a quick check of things. So let me share my screen real quick. 1 second. Okay, so here you go. So once again, welcome all. So this is our fourth meetup on this series, Generative AI in Enterprise. Our topic of the day is chat chaos or chaos engineering on LLMs. And Andrew is our, key speaker. And I'm Ujjwal Bhattacharjee. And all this, YouTube videos, sorry, all this video will be available in our YouTube channel, Curious Circuit. So this is also a fairly new channel. And me being curious about technology is like how we have devise the name Curious Circuits. So now being said that, this is our agenda. We'll do a quick introduction, some disclaimer, housekeeping, participant introduction, and we'll try to keep it very short and hand it over to Andrew. We'll open up the floor for discussions, and this is how you can connect me or Andrew over LinkedIn. The session will be available in Curious Circuits YouTube. Disclaimer, this session is not organized by my employer. This is all my personal interest, nothing to do with my employer strategies or views or position. Housekeeping, if you're feel free to talk and discuss, but if you're not talking, if you have some background noise, so advised would be to, be on mute. Feel free to be on camera. We would like to see you. Again, it's optional. You can also use the raise hand feature on our Zoom as well as the chat function. We're trying to wrap up this by 7:40 so that we can open up for conversation. And so before we jump into chat chaos, I'll like to quickly go around the table and get a little bit one-liner of our participants over here so that we can give Andrew a little bit understanding of like who is the audience. So starting with Jeremy. Jeremy, you want to go first?
Sure. My name is Jeremy DePrisco. I live outside of the Philadelphia area. My background is digital media, specifically music, but also some video production. And I've also got a background in healthcare IT. So I am just really learning as much as I can about how AI is impacting various industries. And I've been using ChatGPT for a variety of purposes, as well as Dolly for image generation, and just fascinated with the whole subject.
Awesome. Silva?
Hey, my name is Salva. I live around the DC area in Virginia, and I have been working with data security, big data security for last almost 10 years. And recently just moved on to the generative AI and in general AI security and governance. So I've been working with the LangChain and the OpenAI and few stuffs and trying to work out, how the chat works and what are the security problems people have and things like that. So I'm interested in learning more stuff from here.
Fantastic. I have next in my list is Cardwell. Cardwell?
Yes.
Yeah, okay.
Yes.
Hey, go ahead.
Yeah. Okay. I'm just a lowly real estate person.
Oh,
I'm
okay.
I'm not an engineer
No,
or anything.
slowly. No, that's
Yeah,
okay. Yeah.
yeah. I am a realtor as well as an appraiser. And I
Awesome.
like to think of myself as a marketer. I'm learning as much as I can about ChatGPT, Dolly, everything that has to do with artificial intelligence. I'm trying to decide how can I use this to my advantage.
Okay, awesome. Fantastic. I'll go quickly. So we have Gopa.
Oh, hi, everybody. Thank you, Ujjwal, for organizing this, and hello, a very good evening. So I'm based out in the Princeton area. My career has been in software engineering as well as IT management. And I've been working in the scaled agile space as well for the last 7-8 years. But currently, I'm working on a couple of startups, primarily employing AI in the pharma manufacturing space. My domain area of expertise is in pharmaceuticals.
Awesome.
Thank you,
Rajiv.
Ujjwal.
Oh, sorry. Rajiv.
Yeah, I'm also in IT management, and I work on testing as an IT manager. And I've been trying I've been trying out ChatGPT and other stuff, trying to see how it can be useful for my organization. So what is more about that? Yeah.
Fantastic. Shiv.
Hi, everyone. I'm currently a grad student at Rochester Institute of Technology.
Awesome.
Before this, I worked as an NLP engineer for 3 years in the field of intelligent document processing. Yeah, so I'm trying to explore generative AI from a more developer and product engineering and product development perspective.
Awesome. Awesome. Joy.
Good, good evening, everyone. Ujjwal, thank you so much for organizing these meetups. I am an attorney with a practice in Districts of Columbia and New Jersey, though I'm spending most of my time in New Jersey these days. My practice entails technology contracts and entertainment contracts. I've recently done a lot of research into rights licensing in entertainment. So generative AI very much talked about in the entertainment sphere. So I'm just trying to stay up to date and be well-spoken on what is going on in artificial intelligence.
Awesome. So that kind of like covers all our your participants over here. Andrew, you have a better understanding for like your audience. So I'll hand it over to you. I'm not going to waste any more of your time. So
Perfect. Thank you, Ujjwal. Actually, do you mind giving me permission to share my screen?
Yeah.
I do want to share the slides.
Always forget about that. So let me actually make you the host so that you can share. Yeah, go ahead.
Okay, I'm the host. Here's me sharing. So let's see. Everyone can see?
Yep.
Perfect. Okay. Thank you, everyone. Thank you for the introduction, Ujjwal. And yeah, really excited to kind of share some of my ideas around chaos engineering and how this might apply to building LLM applications. And I know we have a pretty wide range of different experiences and different backgrounds here. So I'll try to kind of cater towards everyone. So I will say just ahead of time, this talk will be fairly technical. I do have Python code examples that I want to share and I want to talk about, but I'll try to walk everybody through each bit of that in as plain English as possible. But I do think it's helpful to kind of see the code because, if this is a tool that you might be interested in using, you'll want to know how to, how the internals work and how you might want to modify it for your specific use case.
Yeah, Andrew, floor is all yours. So feel free to take it the way you want. And a lot of people I know would actually like to see how the things run behind, the magic that runs behind it. So yeah, feel free. It's
For
all
sure.
a technical deep dive. So yeah, feel free to do the way you want to.
So quick sub-agenda of the bigger agenda. I'm going to do a quick introduction of myself. I'll talk about my experience building LLM apps, just to give myself a little bit of credibility, just to, a level set. I'll talk about what chaos engineering is and how Netflix practices chaos engineering. So this was a really big influence on my thinking of building, on how I built chat chaos. And then I want to kind of pose the question to the group, like, does chaos engineering even make sense for LLM apps? Because I think that's a question that it doesn't have a, I don't have a firm answer in my mind yet, but this is something I'm trying to triangulate on with as many people as possible, right? And then lastly, I'll just go into the technical deep dive of chat chaos. We'll look through a couple of code examples of the underlying implementation, and then I'll talk about, you know, what we did while I was building my LLM application to kind of thwart or mitigate some of the chaotic behavior that you'll typically see from LLMs. And yeah, if you have questions in the middle, I'm happy to take them in the middle as well. I think it's a little bit easier to maintain context when the question is just happening right then and there instead of holding it to the end. But yeah, you can interrupt me or raise your hand. I'll try to keep an eye out for everybody. So I'm Andrew. I'm a software engineer, and I'm also a founder. I'm a member of a group called South Park Commons, which is just a community of builders and software engineers and founders. Specifically, I'm part of South Park Commons' founder fellowship. That basically just means we've raised venture capital from them, and we have obviously the intention of building and scaling a business. Prior to that, I was on the data platform team at Carta-X. I was helping bootstrap that system from 0 to 1. I was the owner of Netflix's Keystone data pipeline infrastructure. So if you're familiar with technologies like Apache Flink and Apache Kafka, that's what I was primarily responsible for at Netflix. And I also worked at Honey. So if you've ever used, you know, the Chrome extension Honey to find you a coupon code while you're buying something online, I actually built the first version of the product catalog there, which powered the drop list feature and the price change notification feature. So that's always a fun kind of story to tell, because I know some of my friends have saved $10 here and there. But the common thread through all of my recent experience is around data engineering, data infrastructure, high-scale data systems, and building resilient systems. And, you know, how does that incorporate into what am I doing now? Right now, I'm trying to bring this lens of data scaling, reliable data systems to building LLM applications. And that's kind of what my approach was when I was building my first product with my co-founder. That's something I'll get into the next slide. That plus, you know, my previous experience at Netflix kind of got me to this point of, okay, maybe there's an opportunity to mix this concept of chaos engineering with building LLM applications. So again, just a high-level overview of myself. I'll continue to walk through the examples. And you can see that on this slide, there's a bunch of blue links there. These are all, there's going to be more links throughout the presentation, so I'll make sure to share the whole slide deck with everyone. And I think you can use this this slide deck just as a reference document for later. Okay, so what have I actually built? What experience with LLMs do I have? So what you're looking at right here is a screenshot of our first product called Admin AI. It's a Chrome extension, and it's a co-pilot for account executives and SDRs to help them automate all of their administrative work that they have on a day-to-day. So the typical day of a salesperson is they're on the call with the customer. After that, they have to put all of their notes into Salesforce, and then maybe they'll send a follow-up email to their customer. We wanted to build a tool, an AI-powered tool, to help them automate all of this stuff. And our quote-unquote claim to fame was that we could automatically update Salesforce with no configuration. If any of you have ever interfaced or interacted with Salesforce, you know that this software is a beast of a software. It can be configured and set up in so many different ways. Every single company has their own way to set it up. And even the process of just configuring it, requires a whole team of Salesforce admins or Salesforce developers. And so what we built was a system that can automatically infer how the Salesforce instance was configured, and then take in the context of a phone call, and then map all of the relevant content from the sales call into the individual fields in Salesforce. We expanded to a couple other workflows. So we generated follow-up emails for the salesperson, and then we also took call notes and produced action items for them. So just to go over what the screenshot looks like, you can see there are 3 checkboxes at the top: update Salesforce, follow-up email, call notes, and action items. All the salesperson had to do was copy the transcript of the call into this big box and click go. And then within 60 seconds, your Salesforce would be automatically updated, follow-up email more or less ready to go, and all of your call notes and action items just there for you. We launched the product, mid last year. We shut it down shortly after, so I won't go into any details about that, but I'm happy to talk about it another time if people are interested. Instead, I'll leave you with an article that I wrote talking about how we actually achieved some of the technical things in this product. The article is called "Updating Salesforce with Zero-Shot Prompting and Almost No Configuration." So this is my experience building LLM applications. We got really great feedback from our early adopters on the product. Unfortunately, it's shut down, but yeah, that's the context. And throughout the whole process of building Admin AI, we encountered bad JSON, like I imagine a lot of you guys are encountering with your interactions with OpenAI's API. On several occasions, sometimes not only did we get bad JSON, but sometimes we exceeded the token limit in our request and our prompt, which actually truncates some of the response, which means it's impossible to get valid JSON if your response is truncated. Our request to OpenAI, they took anywhere between 60 and 90 seconds. This is actually extremely long. So what's the reason for this? We were taking a transcript of a 1-hour phone call and trying to pass the entire transcript into a single prompt and say, hey, what are the relevant pieces for 100 Salesforce fields? It turns out that this task is extremely complex and time consuming. So this is some of the high API latency environment and scenarios that we were dealing with when building Admin AI. You can see I just posted a screenshot of our Notion board with kind of details of the actual error that we faced, just to kind of show the group that this problem is real. It's something that we faced, and it's something that we had to fix. And so coming back to chaos engineering, right? How does chaos engineering kind of enter the fold? I had this previous experience at Netflix dealing with Netflix's chaos engineering systems. I was experiencing a bunch of app crashes in production with Admin AI. On multiple occasions when we were doing product demos, the app just crashed right in front of me and the customer. It was pretty embarrassing, right? As you can imagine, when we were trying to sell someone on our product. And then I think more recently, everyone now is aware of the drama with OpenAI, with Sam and the board, and the outages that occurred immediately after that. It was really like the cherry on top for me to say, hey, there really is an opportunity here to potentially incorporate the ideas of chaos engineering into the workflows of building large language model applications. And so, that's what really prompted me to do a prototype of Chat Chaos. But before getting into the details of Chat Chaos, I want to level set on the definition of chaos engineering. And so there's a link to the website called Principles of Chaos Engineering here. So definitely go to that website, skim it, browse it. It's pretty short, but I'll kind of just state the one sentence definition for everyone. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So I think there's 3 words in this definition that I want to highlight. One is discipline. So what is discipline? Discipline is just an act or a practice that you need to get stronger and build muscle at. I think that's really important in this definition. One is building confidence, right? And so I think this definition is not saying you need to have a perfect system at all times. I think this definition is really more saying that it's okay to have an imperfect system, but you need to have increasing confidence in your system's ability as opposed to decreasing confidence, right? And so it's an important kind of nuance to call out. And then lastly, withstand turbulent conditions. So this is kind of what chaos engineering is all about. And by definition, dealing with LLMs can sometimes be very chaotic. I just picked out a few different bullet points from the Principles of Chaos Engineering website to kind of call out. The website separates the principles into 2 parts. One is chaos in practice, and then one is advanced principles. So I really want to talk about the advanced principles because they're kind of the most interesting and the most relevant. So the first advanced principle is very real world events. Consider events that correspond to hardware failures like servers dying, software failures like malformed responses. This corresponds almost exactly like invalid Json. And also non-failure events like a spike in traffic or a scaling event. So basically it's suggesting, this advanced principle is suggesting you want to mimic events that really happen, not hypothetical failures that could potentially happen. The second advanced principle that I want to call out is run experiments in production, right? Sometimes that might be a really scary thing to do, right? Because you have hopefully paying customers who are relying on your systems. And so I'll caveat this advanced principle by saying it's something that to aspire to do. You don't have to do it. If you can, do it. If you can't, don't. I'll go into more detail a little bit later about how I'm thinking about that. And then last advanced principle, automate your experiments to run continuously. So basically, don't make the chaos engineering system more costly than the actual system itself, right? Make sure you have the right automation, the right tooling, etc., to do it properly, because you don't want this chaos engineering practice to become a burden, right? Chaos engineering at Netflix. So a while ago, Netflix built a open source project called Chaos Monkey. Chaos Monkey randomly terminates your VM instances and containers in your production environment. And the part that I've highlighted here, exposing engineers to failures more frequently incentivizes them to build resilient services. So this was my lived experience at Netflix as an engineer building internal tooling. So I would say definitely check out the project. It's a fun one. Netflix in the early days of cloud infrastructure, when they were migrating their infrastructure from on-prem to cloud, they needed to be able to withstand EC2 terminations. To be transparent, I was not at Netflix at the time. This predates me by a while, but my assumption is that EC2 terminations were happening quite frequently back then. And since then, obviously, AWS has improved tremendously. Internally, what I heard is that their goal was to replace television, right? Netflix's goal back then, 2012, was to replace TV. And so what was said is, if you want to replace the TV, you have to be just as reliable as the TV. And so that was really the motivation for building Chaos Monkey and this tool, which would cause chaos in our systems, and it would force the developers like myself to build applications that were resilient and tolerant to failure. So what does that mean in practice? as a developer at Netflix building internal toolings, we were basically forced to build all of our applications in a 3-node cluster architecture, which means if one EC2 instance in the cluster got terminated for whatever reason, we were able to withstand that. We had 2 remaining clusters, and then if you get super unlucky and the second EC2 instance in the same cluster gets terminated, then you're still able to withstand that situation because you have one more node left in the cluster. So yeah, just having Chaos Monkey running in our production environments really forced us to think about our application architecture and not just our application logic. I want to highlight 2 more pieces of tooling and infrastructure that Netflix built because it really emphasizes the important. Hey, Ian, can you go on mute? Okay, it's okay, I'll continue. I want to highlight 2 more pieces of Netflix infrastructure because it highlights the importance of the culture of operational excellence at the company as something that one of the biggest takeaways from my time at Netflix. So in 2015, Netflix built Chaos Kong, which is a tool that would allow them to fail over all of their traffic from an individual AWS region into other online regions. And in the case of an AWS outage, like EC2 API outage or an S3 API outage, within minutes, Netflix could divert all of their traffic to different regions to kind of circumvent or bypass that outage. The tool was completely automatic. Region failover was automatic, and it's something that we actually practiced regularly. So like on a quarterly basis, we would actually divert all of our traffic in just a simulated practice to make sure that not only were our systems ready for the traffic surge, but our operations teams were actually ready for the traffic changes as well. So that means people being on call, they know how to communicate, they know who to communicate to. It was really just a company-wide exercise in making sure everyone knew what to do in the event of a real situation. And in 2016, the team that I was a part of, we built a Kafka failover tool that's similar to Chaos Kong, kind of mimics the same behavior. In the event of a Kafka cluster failure, we wanted to divert all of the traffic away from that failing cluster to another standby cluster. And so this is how we help keep our Kafka systems available and reliable as much as possible. So last, before I take a short pause and just check for questions, does chaos engineering really apply to LLM apps? And this is the question that I asked earlier. Again, I'm not sure what the answer is, and I think I'm here to listen to you guys and everyone else about what you think the answer is after this presentation. And like Netflix in the early days of cloud, we are also in the early days of LLM application development, and we're just trying to figure out how things work. We're trying to tame or constrain the responses of LLMs to fit the needs of our existing tools and our existing environments. But LLMs are chaotic by nature. And I think this tweet that I have here by Andrej Karpathy, I really like, because I think it shows this kind of dual world that we're trying to deal with right now. But he says, I always struggle when I'm asked about the hallucination problem in LLMs, because in some sense, hallucination is all LLMs do. They're just dream machines. And when I hear that, I think of, okay, we're trying to build a state machine, which is our software. State machines are deterministic. They behave in ways that we can understand and we can debug. And how do we mix that and with a dream machine, right? So we have a dream machine and a state machine. And how do we make sure that these systems are living together nicely and we're able to harness them together in a useful way in our product? But yeah, we can get into the discussion a little bit later. before going into chat chaos, I'll take a pause here, and if anyone has any questions or comments, I'm happy to answer or take any.
I have one.
For my watch, should I just invest in like?
Go ahead, Ujjal. Sorry, I just muted Ayn.
Okay. So I have one question. So basically, you mentioned like deterministic versus dream machine, right? Or rather, in a technical term, maybe like a probabilistic. So LLM is always probabilistic versus like if you're building a workflow, you need deterministic results. So does chaos engineering kind of like help, bridge the gap over there? Or like what is your thought around it?
Yeah, I'm not sure if it helps bridge the gap between these two types of systems. What I think it does is it helps maybe just control one side of the equation, which is just the probabilistic system. So it does so in the way where if you do the practice of chaos engineering, it will force your developers, or it will force your team, your operations team, or your developers to start building the gates around the probabilistic system so that it can be bound by some way. And that's kind of how I see it. I don't know if it's necessarily a bridge or if that analogy it really makes sense, or I guess it doesn't make sense to me, but I'm curious to know what you think.
I don't know the answer, right? So, but it's that curiosity question, right? If I want ChatGPT or any other LLM to tell me a story, it will write a story. But if I can do prompt engineering to let ChatGPT to tell me a particular kind of story. But when it's coming to like workflows, kind of like the ones that you are trying to build, where you get the inputs from the user and the agent conversation and trying to fill in some attributes within Salesforce, it's a very, very deterministic. So it has to be very precise, right? It cannot be, maybe it fits into this particular attribute based on the conversation. So that maybe now it requires some human in the loop to verify that maybe is correct or not. So I really don't know, like, where does this hallucination probabilistic, nature as well as the deterministic, landscape that we are trying to fit into this particular use case, kind of like all fits together, and maybe like maybe it's a completely different discussion altogether and not directly related to chat chaos also, or chaos
For sure.
engineering also, right? I do not know the answer.
For sure.
But it's
Shiv, do you
the
have
question
your
that
hand
is
raised?
going into my mind.
Shiv, you have your hand raised?
Yeah, I do. So when you happen to mention about production-related issues in chaos engineering, so when I used to work as an NLP engineer, mainly using transformer language models, so we were asked to export our models such that it can run on a lower compute system in order to reduce costs. And usually what we noticed was a downgrade in performance, but an increase in speed. So that was a trade-off which we usually used to tell the customers or whoever used to use it at the end. But there's one thing I can think of is, let's say, like in your Netflix example, wherein you randomly turned off a few nodes, and because of which the compute power reduces. So, can you think of a situation wherein you can build a mechanism to enable the LLM model to adapt and retain the same performance level irrespective of what the compute power could be? Can that be, because that has a state randomness in it, if you think about it. It's so yeah. That's
Interesting. That's definitely interesting. Let's I have a couple of ideas, but I'm not sure how to explain it yet, but maybe we can connect offline after this and talk about it. Are you familiar with local LLMs or LLM routing? Maybe some of these approaches could be helpful. Okay.
Okay. Yeah, we can discuss further. Yeah. Yeah.
Okay.
All right.
Okay, cool. Okay, so chat chaos. What is chat chaos? Chat Chaos is a LangChain chat model abstraction that's inspired by Chaos Monkey. So LangChain is a LLM application framework slash SDK slash something else that seems to be able to do everything. But Chat Chaos is built on top of LangChain, and the reference to the good, the bad, and the ugly is a reference to the three core features of Chat Chaos. First, Chat Chaos can make your LLM return invalid JSON. It can make your LLM really slow if you want it to be. And it could also make your LLM hallucinate, right? And what's nice about the Chat Chaos abstraction is that you can use it like you use any LangChain chat model. So the code snippet that I shared on the right is a very simple LangChain chain. At the very top, you can see how Chat Chaos is configured. You basically have to supply a model, an actual LangChain chat model to the model parameter. You can configure the parameters with however functionality you want the Chat Chaos abstraction to exhibit. And then you simply insert the chat model into the chain just like any other chat model. Oops. Subclassing, or sorry, creating Chat Chaos is actually really easy. All you have to do is subclass LangChain's base chat model. And this is a pattern that I had been experimenting with a lot. I actually think it's a nifty approach to augmenting the functionality of your existing LLM. And so I definitely recommend trying it out and seeing what interesting things you can do with it. It's really easy because all you have to do is implement two functions. One is LLM type. All LLM type does is it returns a string, which is the name of your chat model. And then the second function, generate, which is the more important one. This is where all of your custom logic will be. And like in Chat Chaos, this is where all of the manipulation of the data and manipulation of the LLM response happens inside Chat Chaos. So I'll go into detail in a little bit with more code examples, and also the source code for Chat Chaos is available for anyone to browse, and there's a link at the end of the presentation. Chat Chaos has a number of different configurations. So first is the model. It's required. You just have to specify which model you want to augment with chaotic behavior. There's an enabled flag for you to set true or false. Usually you'll want to use this configuration based on your environment. So for example, if you're deploying your app in a development environment, you can set enabled to true. But if you're deploying your application in a production environment, maybe you'll want to set enabled to false because you just don't want to impact your users. Next is the cron slash chronometer parameter. So Chat Chaos runs on a cron schedule. It doesn't run all the time. So you have to give it the schedule for how often it runs. So for example, you can say, hey, every Monday at 1 p.m., I want Chat Chaos to make my LLM have chaotic behavior. You also have to specify the duration for how long you want it to run. So you can say, every Monday at 1 p.m., I want Chat Chaos to run for 30 minutes. And then, to give the developer a little bit more granularity, you can also supply the ratio parameter, which is basically just a percentage. So in this example, you're looking at the default value, which is 0.01, which means 1%. So to go back to my example, I can say I want to run Chat Chaos every Monday at 1 p.m. for 30 minutes, and I want 1% of my request to the LLM in that 30-minute period to exhibit chaotic behavior, right? And so this schedule and ratio configuration really gives the developer fine-grained control for when this chaotic behavior is going to happen. each of the good, the bad, and the ugly can be turned on or off individually just with the Boolean flags. So you can see enabled underscore and then the behavior name. And then for some specific behaviors like hallucination and latency, there are additional configurations where you can specify, a hallucination prompt and also the minimum and maximum range of latency that you want to add to an LLM request. So for both of those last two configurations, I'll go into exactly how they get incorporated into the implementation. Malform JSON does not have any additional configuration, so it's just you turn it on or you turn it off. Invalid JSON. So I'll talk a little bit about some of the stuff that we experienced while building Admin AI. Because we know that large language models are trained on a lot of markdown content. Whenever you request code or you request JSON from a language model, sometimes it'll return triple backticks and surround the JSON. But if you try to just take all of that content and parse it, you'll get an error. There were other times when we were asking for a JSON response from an LLM and we simply exceeded the token limit. So we got truncated responses. That's kind of what I was referring to back in a previous slide. And then in really, really rare cases, although we saw this a couple times, sometimes instead of JSON, we actually got back a Python dictionary. And the subtle difference between a Python dictionary and a JSON object is that a Python dictionary is printed with single quotes and valid JSON is printed with double quotes. So this actually makes a huge difference when you need to parse out the response from your LLM. And so I'll get to you in 1 second. I'll just quickly go over the code snippet at the bottom. Not too important to understand what's going on, but I do want to kind of direct everyone to the bottom half of the code, the 3 if statements. You can see that the implementation of chat chaos is simply augmenting the response from the LLM. So in the first if statement, you can see that it's injecting the triple backticks around the content. In the second if statement, you can see that I'm truncating the last character off of the LLM generated response. And then in the last if statement, you can see that I'm replacing all of the double quotes with single quotes. And this is just a mechanism to force the response to be invalid JSON so that it's basically just a guarantee. Because similar to how you can't rely on an LLM to produce a valid JSON, you also can't rely on it to produce invalid JSON, right? So this is the only way to do it. Ujjwal, if you had a question or comment?
Yeah, so basically this chat chaos will it be part of or as such chaos engineering, like will it be part of our regression test suite when we are running? When do we introduce this? We do not want to introduce this in production, right?
We'll get to that exact question in a couple slides, but I'll also just say quickly, yes, this can definitely be part of your regression testing suite or your regression testing process. But I'll say it's not the chaos, it's not the chat chaos code that you're testing. It's actually the code that you build to surround your LLM that you actually want to test and you actually want to flex, right?
Okay.
So we can get into this. Yeah, we can get into the discussion of whether or not to run this in production or not, because it is a tricky one. So what did we do with all of these errors? So our approach when building Admin AI was to always try to fix forward the JSON error. In contrast, the alternative approach is to just retry, right? You can always make the same request over the LLM and hope it gives you valid JSON. But we took a different approach. We felt like the number of types of JSON, invalid JSON errors is actually limited and it's well defined. And so we built a pretty sophisticated JSON parsing / JSON correcting mechanism to make sure that we would always get a JSON object that the Salesforce API could accept. And it sounds like really hairy and really messy, but it really wasn't. My suggestion and my advice is try it. It's worth the effort in my opinion. And if you really can't build a system to do it, then of course retry is always available. Another tip is always have default values for missing keys. So sometimes the LLM will respond without the full set of keys that you asked for. Sometimes it responds with keys that have the wrong capitalization. This is something that we also faced. Sometimes the keys were snake case instead of camel case. You know, it's not a perfect system. So make sure that you always have smart defaults, you know, just like with any system, not just with dealing with LLMs. And then if possible, avoid nested JSON. I think we actually hadn't tested this ourselves, but my intuition is that asking an LLM to produce really complex, deeply nested JSON is not a good idea. And so much better to just go with single level nesting, flatten JSON keys, and make it easy for the LLM to succeed, basically. And then in turn, you handle some of the complexity on your application code side. So that's kind of a trade. Increased latency. So like I mentioned before, it could take up to 90 seconds, so a minute and a half for GPT to process some of the prompts that we were sending, because we would basically put the full 1 hour phone call into a single prompt and ask Salesforce to, hey, pick out 100 fields from this call. So we didn't implement token streaming, right? Because the Salesforce API cannot take in a stream of tokens. And so in chat chaos, you have the mechanism to specify the minimum amount of latency that you want to add and the maximum amount of latency that you want to add. It'll just select a random value in between those two numbers. And then you can see at the very bottom of this code snippet, it's as simple as calling time.sleep, pass in the random delay, and then your system is basically waiting, right? Jeremy, did you have a question?
Yeah, so I'm a very mediocre programmer, but I have a question. One of the things that I like about ChatGPT is I could actually ask it to write a snippet of code or analyze something and tell me if there's some options I'm not thinking of. And for my purposes as a mediocre programmer, that works. I know that's not always perfect, but it is the way I always thought programming should work, that the programming is, I'm collaborating, you know, they use this term collaborative programming. So when you say that, you know, you're having trouble with syntax between Python and JSON, my question becomes, why isn't part of this system helping you eradicate that from even happening? And maybe that's a simplistic question given the fact that I am a mediocre programmer.
It's not a simplistic question at all, and I'll kind of share what my thinking is around this. So you're basically describing an iterative process to get to a final output that is something that you want, right? And you can go back and forth with the LLM. We can actually do the same thing in the use case of producing valid JSON. We can say, hey, here's my prompt, give me back valid JSON. And then I can build a system that receives the response and says, hey, this doesn't look like valid JSON. Go back to the LLM and ask it to correct the errors. And you can do this in a loop until you get back to valid JSON. And all of this can actually be automated. It's conceptually straightforward to do. It's exactly as you're describing. And so now the question is, why don't we do that? The answer is that there is a cost to that back and forth iteration, right? There is a cost in terms of latency. There is a cost in terms of basically paying OpenAI, right? You have to send the tokens over, right? And tokens cost money. So this approach of iteratively, you know, working on a response is a starting point. Eventually, you're going to want to find ways to optimize and reduce the cost and reduce the speed. And I think the approach of chaos engineering maybe not at the top of the list in terms of things that you want to try first, but it gets inserted towards the end when you're really needing to squeeze out really high performance, or you're really needing to be hyper resilient against a certain system, or maybe the context of your business is I can have no failures, right? Maybe that's it. And so again, it's a picking and choosing kind of scenario, but I think you're totally spot on about leveraging the LLM to iteratively correct something.
Thank you.
Shiv, go ahead.
So an extension of this question, you happen to mention that sometimes the returned output of the LLM could have missing JSON key values. So I have a question for you, which is, would you be able to treat this as a prompt engineering question, where the input could be the JSON key prompt and the corresponding output would be the generated value, such that you, in this case, you eliminate the possibility of missing keys and some keys getting capitalized, and yes, those cases. And if so, what is it?
So, but believe it or not, that's what we did. We supplied the exact keys that needed to be returned in the response, and in some cases, it still did not succeed in returning the exact keys. So yeah, it's just you can never. It's just not a guarantee, basically.
Okay, understood. Okay, thank you.
Yeah. Okay, so what did we do about the increased latency? What we observed from our users is that they actually, when they were interacting with the Chrome extension, because the response took so long to return, we would see that users clicked away, like either to another tab in their browser, and then unfortunately, what happened in our first implementation is that it cut the request context off. So when they reopened the Chrome extension, it was never able to receive the response on the other end. And so after we realized that this was happening, we updated the Chrome extension to be a little bit more sophisticated and a little bit more smart. It would maintain state of the request, and basically, yeah, it was able to kind of resume polling for the request basically after the user had clicked away. So this is, the impact of a long request time was kind of the forcing function for making us update the Chrome extension. And so that's kind of the tip here. Make sure to check all of your client timeout settings, especially if you have a system that's of many parts, and the response has to propagate through many different systems. And also, easy tip: build an asynchronous user experience for your user. Don't make them wait. Let them do other things while a request is in progress, and make sure they have some kind of feedback so that they know your app is not frozen. Yeah, for example. Ujjal?
What about like parallel processing, like chunking the whole content out into like smaller chunks, send it into the LLM as parallel, and then getting the response, summarizing the responses into some context? Maybe not great, but this is something that I did for a similar kind of thing. But of course, like I was not filling up like Salesforce fields and all. I do not have to be deterministic.
You're totally right about your approach, and that's exactly what we did with Admin AI too. Yeah, so I would highly recommend reading the How to Update Salesforce with Zero-Shot Prompting, because I go into a lot of detail about how we segmented the call into multiple parts. We executed the API call in parallel for each part, got the response back, chained them together into a JSON object, and then sent it to Salesforce. And the risk, it was actually super effective and quite underrated. I think the big risk is that doing that at scale risks hitting the token limit. And I think back in mid 2023, the limits for GPT-4 were actually quite low compared to where they are now. And so maybe this issue is not a big issue.
I think, right around that.
Yeah, and so that was an issue for us a few times actually. But yeah, chunking and parallelization was super effective for us. Okay, hallucination. So I think this is the feature that is the most unknown in terms of its value. So I'll kind of just talk about how it works. If you recall, the developer has to specify a hallucination prompt. Basically, what we do is we inject that prompt into the end of the original prompt so that the final output is not necessarily like what the user wants. And this approach was really just a balance of, security, safety, developer control, making sure that, we put the outcome in the hands of the developer and not the client library, but also ease of implementation, right? So this was fairly easy for me to implement. It's simply just doing some kind of string manipulation here to manipulate the original prompt before sending it to the actual LLM. And I will say, I actually tried to get ChatGPT to hallucinate, and it's not easy. And I'm fairly confident it's against the terms of service of OpenAI, so just don't do that. But you can put in your own dummy prompt through Chat Chaos here. So what do you do when you get a hallucination? And I think it's really tricky because hallucinations are not failures in the software system, right? It's actually just a failure in the content. So it's not like you're getting an API timeout, you're not getting rate limited. It's not necessarily, the API response is not necessarily slow. You just got your system thinks it got content that made sense, but your user's looking at it and your user's saying, hey, what the heck is this, right? And so what we did in Admin AI is we built just a really simple mechanism for collecting feedback from the user. It was just an interface where they could give a thumbs up or a thumbs down about any piece of AI generated content. And we would occasionally go through all of our thumbs down feedback and do just more thorough investigation on what's actually happening in this particular case. In the long term, there may be a need for more of a real-time system to collect this feedback and act on it. And then the next level after that is a real-time detection system for checking if your response is a hallucination or not. And so I don't know how these systems might work. I have ideas. They're just different approaches. But yeah, eventually, if you're dealing with hallucinations in 1 out of every 10,000 responses, you might be motivated to try to build a system around this to catch hallucinations, just depending on your business context. So in practice, Chat Chaos, it's pretty easy to implement, copy, extend, modify, whatever. The Python code is fairly straightforward and it's available on GitHub. I would say first start by experimenting in your development and QA environments. No rush to go to production yet. Like the LLMs are probably already hallucinating anyways. Build some level of confidence with the system. Build confidence with the systems that you build around it. Make sure your teams know how to operate it. Make sure your teams know how to shut off chaos engineering with one button click. Make sure people know when Cat Chaos is running versus when the actual chaos is happening, right? And also, be cognizant of your context. Are your users going to be forgiving if something actually happens in production? And so again, I go back to the example of updating Salesforce, right? So what's the context behind that? When we talk to a bunch of sales people, the context was that they didn't update Salesforce anyways. There was nothing in there. And so failing to update Salesforce was not an actual critical problem for them because they just weren't doing it anyways. And so, given that context, maybe we have some more leeway to experiment with chaos engineering in production environment. Now, let's say, hey, you're a financial auditing firm, you're trying to read reports in all different formats, and then you're trying to update QuickBooks or something like that. Okay, maybe this context is a little bit more risky to do chaos engineering. Use caution, use really good judgment. It's really difficult to quantify and measure the performance of an LLM. One of the principles of chaos engineering is that you want to be able to measure a steady state of your system. I think this is something that's actually quite difficult to do with LLM, so I'm not actually sure if this principle reconciles with using chaos engineering in your LLM application environment. Lastly, minimize blast radius. Start small, start with one application. You don't need to go to your main one with all your users. Again, build confidence slowly and over time. So last question I'll pose for everyone else. You don't have to answer. What other types of chaos should be mitigated and should we protect against? So something thinking exercise for everyone. And then here are the links to the original Chat Chaos article that I wrote on Medium if you didn't get a chance to read. Chat Abstractions is the GitHub repository where Chat Chaos lives, and a bunch of other chat abstractions that I've been experimenting with. If you're interested, you can follow me on Twitter, and I occasionally write on other articles on Medium. So here's a link to my Medium and also a couple links to some of the other articles that I wrote. But that's it. Thank you for listening.
Thank you so much. I think this was extremely well crafted and very, very much informed, presentation. Can I take the share screen back or the hosting permissions back?
Yeah, go for it.
Okay. Anyone has any? I don't think I'm still the host. I'm not able to share my screen. Andrew, you're still the host.
How do I make you the host?
You have to just right click on my name and then. Okay, I can reclaim host. Okay, got it. So thank you so much. So now, anyone has any question to wrap up?
Joy, go ahead.
Yes. So my programming tools are rudimentary. This is more of a business question. You talked about a lot of the problems you have when you're doing that API call to the GPT-4 platform. So I know at least from the consumer level, access is not equal for everyone to GPT and to Chat GPT. Is there a hierarchy in the access that developers will have to the system? And if that access had been enhanced, would it have removed some of these problems that you had? And if that's the case, are there business reasons that you might not have gone for that enhanced access?
Okay, I think I understand the question, and I will answer in the context of our experience, and let me know if this makes sense. So in the early days of building Admin AI, we didn't actually have access to GPT-4. We only had access to GPT 3.5. That meant a lower token limit, so you can't send as much information to GPT 3.5, and also generally less powerful functionality from GPT 3.5. And we actually had to build a lot of functionality around our application to get what we wanted to happen, which was ultimately to automatically update Salesforce. At some point later, we were granted access to GPT-4. So that would be the example of like developers having tiers of access through some period of time. That made our life so much tremendously easier, right? We had a much bigger context window, which basically means you can send in more information. So to kind of put this in a real world example, when we were using GPT 3.5, we could only process a phone call that was 30 minutes long, right? Half the time of a typical sales call, which could be up to 1 hour. It's just because you talk less in 30 minutes than you do in an hour, right? So we actually had to build a lot of surrounding functionality to be able to use GPT 3.5 to properly process a call. Once we had access to GPT-4, everything became so much easier. We got to remove a lot of our functionality. I don't think there was ever like a business decision that would make us choose one or the other. I think we were just in the mindset of always just having the expectation that we would have access to the next level at some point in time. And it was really about mitigating the challenges during the time that we were in the lower tier until we got to the higher tier. Let me know if that makes sense. I'm not sure if that answered.
Yes, that makes sense. With respect to going from GPT 3.5 to 4, once you had access to 4, once a developer has that access, are all developers treated equally, or do some developers perhaps get a faster turnaround time? So your product is not going to have as much latency.
My understanding is that all developers have equal access to that level if they had been, or equal, I guess, functionality at that level that they were granted access to. So if I'm on GPT-4 and my co-founder is also on GPT-4, there's no way that my version of GPT-4 is faster than his if we are just using it exactly from OpenAI. That's not to say that he could run a completely different model that is much faster, but he's running a different model, right? And so, yeah, it should be all equal.
Okay,
Andrew,
we'll just
I can
take
add
the
some
last
comment.
question. Yeah, Selva, please go ahead.
Actually, I think this is related to Joy's question. Basically, she's asking, does different users will have a different access to the LLM? By default, LLM doesn't have any concept of which user it is and what they have a privilege to. You just ask questions and it basically answers back. But there are effort to build a security and governance around it so that if Salva comes and asks, it's going to first verify whether you have access to LLM. And if you don't have access to LLM, then it's going to stop there, right there. You don't have access to it. And sometimes it will allow you to go and ask the question. And then when the answer comes back, it will be able to actually figure out whether this answer is appropriate for me to actually return back to the user. Like, for example, I can ask, hey, what's a pay rate for Andrew? And that will go there and I'll find out the information. But then when it comes back, it's going to actually scan the answers and says, hey, this information is privileged only for executives. So I'm going to tell you that, hey, this answer is restrictive. Or you ask some questions which is not appropriate within the corporate settings, it can actually identify. So these are the things that are actually being worked out outside the LLM, which is actually one of the things that if you want to check out, there is a privacy.ai, which they have some filters that allows you to do this access control for governance. So on top of this, I wanted to ask one more thing. I know that you are introducing chaos in the world to make sure that your application is written in a right way so that you can handle all these things. So I think one of the things that we should talk about is how do we actually handle these security issues? So what about if our data is getting leaked out? Is your application is capable of capturing it and able to stop it instead of actually returning back to the caller?
Yeah, I think you're kind of calling out another form of chaos, which is like data leakage, right? And again, chat chaos won't prevent that. It can simulate that, but it's up to you. It's up to you to build the surrounding system to catch that, right?
Yeah, I'm just saying that we should add these kind of scenarios into the chat chaos so that whoever is using this framework to actually test it, they will be able to actually kind of make sure that they are able to handle it in the application.
Yeah, that's really interesting. I didn't consider that, and I'll definitely make a note of that.
Awesome.
Okay, so just a quick check of time. We are already over by 11 minutes, and I know like a lot of interesting questions are coming up. So feel free to connect with Andrew over LinkedIn. You can feel free to connect with me also, and we can always like brainstorm. And also, if you have any thoughts about like any further topics that you are interested to learn or present, let me know. We can collaborate and organize. So being said that, Andrew, thank you so much for taking time out of your busy schedule and giving time for us to like learn and, enlighten our knowledge base.
Of course. And I
Thank you.
learned just
Mhm.
as much as well.
Yeah.
Hey, thank you, Andrew. This is very, very useful.
Yeah, very, very useful. And thank you everyone for the participation. See you next week.
Thank you.
Thank you.
Thank you.